In today's video, we'll be going over an explanation of Task 1 using the AWS console. Here, we have a rough overview of the steps we'll have to take. The first step is to provision security groups, which we will later use and attach to the resources, like the instances that you will launch. Let's head over to the AWS console now. Let's start by heading over to the EC2 page. Once there, scroll down until you see the Security Groups tab. Click on it. There, click on Create Security Group. We will need to create two new security groups, one for the web service and the other for the load generator. Let's start by creating a security group for the load generator. I will call it Load Generator Security Group. Make sure to also give it a description and keep it in the same VPC. We will need to allow a rule to enable incoming HTTP traffic. So click Add Rule, specify the HTTP service, and allow it from any IP address. Make sure to add any additional information as specified per the write-up, for example, the project tag. Note that the project tab I'm using here may differ to the one that you have, so make sure to double check the handout. Then click Create Security Group. Once complete, you can follow a similar process to create the security group for the web service. With the security groups now provisioned, we can create a new load generator instance. Thanks to the primer, you should be familiar with the process of launching an instance from the AWS console. But let's go over it again using a custom AMI. Head over to the Instances tab and then click on Launch Instance. Here, give the load generator an adequate name. In my case, I'll use LG. Make sure to add any project-specific tags to avoid the tagging penalty. For the image, head over to the write-up and locate the load generator image ID. In my case, it's this. With that, head over to Browse More AMIs and copy-paste it here. Then, head over to Community AMIs and select the load generator image. With that, we can then set the instance type as per the write-up, in my case, m5.large. For key pair login, we can leave this as proceed without a key pair, as we will not need to connect to it. And for security group, we can click Select Existing Security Group and use the one we created earlier. Everything else can be left as default. With the instance now launched, wait until the instance state is ready before trying to connect to it. Once it's running, make sure to copy the public IPv4 DNS and open it in a new tab. If you get a can't connect to server, this means that the server is still booting up and needs some time. Wait a couple of minutes and try again. Once the load generator is ready, you should be greeted with this page. If you do not see this page, it means something is wrong. Most likely, you've selected the wrong AMI. So go back and try again. The next step in the process is to launch the web server instance. This will involve the same steps as launching the load generator, but using the web server AMI and a security group created specifically for the web server. Once the web service has been created, we should be able to click on it, copy the public IPv4 DNS, and copy-paste it into a new tab. If everything worked correctly, we should be greeted with this page. You should also be able to click on Look up a random user, where you'll be greeted with a random number. Again, if you're not greeted with this page, double check the security group and the AMI you used. The next step is to authenticate with a load generator. Revisit the tab where you have your load generator open and click on Enter your submission password. Here, log in using the credentials provided in the write-up under Show Submission Credentials. If you have entered everything correctly, you should see You have entered your submission password. Otherwise, you might have accidentally introduced some white space when copying over your username and password. Now, we can start the horizontal scaling test. Head over to the load generator homepage. Once here, click on Horizontal Scaling Test. we'll need to enter the DNS of the web service we initially provisioned. Head back over to the EC2 homepage, find your web service, and click on the public IPv4 DNS. Copy that, head over to the load generator, and paste it here. Then click Submit. You should see Test Launch, and if you click on the test, you should see the logs of the current test you are running. After some time, if we look at the logs, it becomes clear that one web server instance will not be enough to reach the target RPS of 50. We will therefore need to launch and register more web server instances. Follow the same steps as before to create a new web server instance, and once that's complete, copy down the public IPv4 DNS. With it, head back to the home page and click on Add Instance to Horizontal Scaling Test. Then, paste that DNS you copied from before and click Submit. After some time, you should see that new instance popping up in our log to verify that everything went correctly. We should hopefully also see how our RPS went from 9 to 22. With this, you should now be ready to programmatically simulate exactly what we've done using the AWS SDKs, and thus be able to complete task 1 to reach a target RPS of 50 within the 30 minutes.